Well, hi everyone, and greetings. This is Bob the Science Guy talking to you from Shamrock Banks Observatory. How is the audio looking out there? We got good audio right now? Sorry about a couple minutes delay there. Unfortunately, for some reason, my Streamlabs settings were all gone for this channel. It took me a moment to reset them. So can you guys hear me okay out there? Looks like we've got a few people in the chat. We have audio? Audio is good. All right. Well, I'm starting off with something a little bit different tonight. Right in the center of the screen, you have what is called an open star cluster. Now, we've seen globular star clusters in the past, but this is an open star cluster. And let's see if I can make it a little bit larger. Let's go up to about 100%. No, it's a little too large. Let's go down to 50% and see what we have there. So this is what's called an open star cluster. And as you look at it, hey Otis. Otis is coming over here with a mic. But even looking at 33% Hail Sagan, you notice that there's a collection of stars right here, and there's a lot more stars in the center than there are out in this area. That's why this is an open star cluster. It's not like M13. Where are you? San Diego. Very good. So that's why this is called an open star cluster. It's not as well defined as, say, the Great Cluster of Hercules or some of the other ones. But it's kind of an interesting cluster. This is called Carolyn's Rose. And it is named after Carolyn Henschel, who is the is the sister of William Henschel, who was an early astronomer. And this cluster was discovered in 1783. It's about 6.7 thousand light years away, 6,700 light years. And as I said, it was discovered by Carolyn Henschel. Now, the interesting thing, according to my son's astronomy professor, is that she was the first full-time professional female astronomer. And she, as I said, she was William Henschel's sister and worked hand in hand with him. Hey, Mr. Dawson, how you doing tonight, Dick? So, in light of our change here in the presidential election, I thought that I would highlight a female astronomer starting right off from the bat. So, this is Carolyn's Rose. Now, we have a lot of different targets that we can hit tonight. We are using the RASA 11 telescope. It was collimated last night. It was cleaned, serviced, and reinstalled in the dome about a week or two ago, but last night was the first really clear night that we had. And I installed the Color ZWO 6200 camera, and last night I collimated it. The interesting thing about RASAs is that they have a very low focal ratio. It's only 2.2, and especially given the very large sensor on a ZWO 6200. Hey, thank you very much for the super chat there, Jeremy. But, that was 19 days ago. Sorry about that. But in any event, the RASA requires that the sensor on the camera be exactly square to the light path. And by being flat to the light path and perpendicular to it, I mean to within 7 microns. And a micron is 1/1000th of a millimeter. And as a result of that, it's a very involved process to collimate a RASA. I have what's called a photon cage on the front of the RASA, and the camera is mounted in that. And it allows me to very, very carefully adjust the tilt of that sensor. And over the course of about 2.5 hours last night, I was able to get the RASA collimated to within about 3 microns of being perfectly perpendicular to the path of light. So it's focusing very nicely, and as you can tell, we don't have any distortion in the field. It looks really nice. I'm not shooting flats or darks with this. This is just live stacking with Sharp Cap. So there's Carolyn's Rose. Now let's go ahead and stop the live stream, or the live stacking, and we're going to drop our exposure down to about 4 seconds here, just to kind of see where we are. And once we get that done, when this little bar is done, we'll go ahead and hit stretch. So you can see the remnants of Carolyn's Rose right here. We were doing 60-second exposures. Now the next thing that I'm going to do is I'm going to go ahead and stop guiding for right now, because we're going to be moving around a little bit. Now, these are our available targets tonight. And give me just a second, I want to go grab something. Well, shoot, I must have done something with my magnifying glass, because I'm having a little trouble reading this right now, but let's go see what we can come up with. So tonight, because we have the color camera, and it's a relatively nice night, the moon hasn't quite come up yet, I thought maybe we'd have a look at some nebula. So the one that I want to have a look at here is the Eastern Veil Nebula. Let's see if that's up. And indeed it is. So let's go on over there. Kind of have a quick look and see how the what Bortle class am I? 4. However, they're dredging the lake 24 hours a day right now, and these dredges have what appear to be aircraft landing lights on them. They're actually being pretty good about not pointing those lights directly at the observatory, but they're just not making it it's not helpful. And especially when the moon comes up, we're also going to have some issues there. So we've gone ahead and done our focusing and such here. So we're going to come on over here. We're going to turn off the camera on Sharp Cap. Although before I do that, let's go ahead and see whether or not maybe I can plate solve this. Let's see if it'll plate solve. I've had some issues with it plate solving. Well, it did. There we go. So we may not have to worry about that right now. So you see it's making a very slight change in the orientation of the telescope. There's a satellite going by. Did you see that? So let's go ahead and get a full image here. We should be locked on to where we want to be, but I think that what we need to do is we need to go ahead and we need to take a longer exposure. So we're going to go ahead and just let's see if we can take a 60-second exposure. Actually, let's see if we can go for 90, but what I do need to do is I need to go ahead and start guiding here. Okay, so we got a good guide star right there. So we're going to start guiding. We have sub-arc second guiding tonight, so we're in pretty good shape with that. Now, we may not have much luck with this very first image because guiding just started and there may have been a little bit of movement. So we'll go ahead and clear this off. That looks pretty good. We're going to take all the stretch out for right now. Yeah, it was a pretty impressive collimation, Dick. That's one of the reasons that I got the photon cage, is if I'm going to be doing science with this, I really need to have perfect collimation with it. I mean, this entire thing is geared up to do sky surveys, and I need to have excellent focus from edge to edge. And if I have sensor tilt, it's just not going to work. OKS, Southeast Australia. I have friends in Australia. I've always kind of liked Australians. Oh God, you used LEDs? Yeah, you went from a 5 to a 7? Yeah, so here's the Eastern Veil Nebula. You can just barely make it out right here. Can you just barely see it? Let's go see what happens when we normalize the colors. So you see these the color curves here? You have red, blue, and green. Notice how they don't line up. But if we come over here, we line them up. You see how they're lined up now? Now the next thing that we want to do is we want to go ahead and put a little stretch in this, because all the data is from this peak to about right here, and we want this curved line to go right here from where the slope, or the dy over the dx, goes from being very steeply negative to shallowing out. So when we hit that, watch what happens to the image. And that, ladies and gentlemen, is the Eastern Veil Nebula. We want to adjust that just a little bit more. It's a little, about right there. Let's see what that looks like. A little more. That looks pretty good. I like them looking a little bit ethereal. So this is the Eastern Veil Nebula. Let's get a little closer look at it. Bring it up to about 66%. Hail Sagan. And you can see some of the fine detail in there. And this is, of course, true life color. So you see it's mostly red. It does have a little bit of this green in it. These are the different elements in the nebula. Let's bring this down just a little bit more. Let's go down to about 33. Yeah, maybe even a little bit less. That looks pretty good right there. So we're going to let this kind of come out for a minute. Now, what we're doing is called live stacking. And what it's doing is it's taking image after image. Each image is about 90 seconds long, and it's going to just take image after image, and it's going to stack them one on top of the other and line the stars up. And as a result, the background will become a little bit less grainy and a little more uniform black. And the nebula itself will appear to get a little bit sharper because it's going to average the positions of the little red areas, and it's just going to sharpen those up quite a bit as it stacks. So let's see how our guiding is looking really good. We're right around an arc second or a little bit less on our guiding. And this, ladies and gentlemen, is how it's done. But this is the Eastern Veil Nebula. The only filter that I have in my image train right now is I have a light pollution filter, which is made by Celestron and replaces a clear glass disc that is in front of the camera in the secondary mirror, where the secondary mirror would be. So there's a little bit of light pollution filter on there. I still have quite a bit of issues with light pollution. I do have my porch lights off, but as I said, they're out dredging in the lake, and there's a lot of very bright lights out there right now. COS? Tell me exactly what you mean by COS. Unless, of course, that means can lovers shoot? Yes, we can. So let's go see what this looks like. That's 25%. Let's go see what it looks like. So you see our stars are looking nice and round. And man, look at the amount of detail we're getting in there, even with just a couple of images stacked already. See how wispy the nebulosity is? This camera does a really fine job on nebula. Now you can also tell, the difference. You have the red stars and you have the blue stars and the white stars. That little green star right there is not a star, that's a hot pixel. But you see just the beautiful coloration in this nebula is just amazing, isn't it? Look at all that. Now, just to show you what stacking does is let's leave it right here for a minute and let that stack for a few. City light suppression. Oh, that's not interesting. You could have at least made something cool up. Yeah, basically it's city light suppressing. We call them light pollution filters here, or at least that's what I've always been taught that they were called. Since you do mention it, I actually have a Hulu, which means that I can put YouTube on my TV as well. I think I'm going to go ahead and do that. So in the background, I have the little one right here that I'm doing, but I can actually see, I'll actually be able to see it on the main TV, which is like a 54-inch TV or something or other. But isn't that just beautiful, the amount of detail that you're getting with this? Yeah, let's go on over here to YouTube and see what it looks like. I think that's it. Give me a second and let me get my my channel running. I'll be right back. Bob the Science Guy. All right, so now I've got the channel up. Let's go see what we have here. Yeah, that's pretty amazing. All right, so let's go ahead and reduce this just a little bit. Let's go down to 25% again. And there it is. So that's what a nebula looks like. This should be at full HD. I'll double check it and see what we have. But in any event, let's go ahead and have a look at a couple of other ones here. So that's the Eastern Veil Nebula. I'll double check the stream rate just to make sure it's the highest quality that we can get. What are you reading on your end? Now you see right here, we're starting to get a little, see this light area right here? That means we're probably starting to get a little close to the dome. This edge of the dome shutter right here is probably catching the guide camera, which is going to be in this area. And that's why we're getting a little bit of white over there. But let's go see if we can find another nice target here. This should be a good one right here. I think you may like this one. Hey, Nico. I'm in 1080p. All right, we'll bump that up. So what I need to do is I need to let the dome quit rotating. And what will happen is first we'll lock on to the target. You know, once we get the dome all lined up, we'll go ahead and lock onto the target. Do a quick plate solve to make sure that we're pointing in the right location. See the track and the rollers that the dome is moving? So the telescope and the dome are both moving. That's the charging station for the shutter motor. Looks like we're going to be pointing about south, so we won't be able to stay here long because we may end up with a meridian flip. Well, let's go ahead and see whether or not maybe we can fix this. We'll give it a second to come around. So the dome's reading about 200 right now. I don't know what the deal is. It seems like every single time I do this, I always hit the wrong rotation first. Okay, that looks pretty good right there. All right, so we're going to have to adjust this dome here just for a second. See, did it again. What I did was I turned the tracking of the dome off. because when I adjusted it last time, what it did is tracking was on and it went right back to where it was. So now we'll sync that as the correct location, and we'll turn tracking back on. Then we're going to go on over here. Let's get a nice image. See if we can point solve this bad boy. So if that turns green up there, it means it's got a solution, and it does. And we're generally about 1.5 degrees off when we do a big slew like that. So give it a second just to kind of get lined up to where I actually told it to be. And I think we probably are there now. Let's go ahead and start the guide camera again. So you see we're kind of clipping a little bit of that dome. So we might want to go ahead and just move that over here. Let's not make the same mistake we did here a minute ago. We'll turn that off. So what we want to do is we want to move it back. Hey, I moved it right the first time. So I moved it back. I backed it off just a little bit to give the guide camera a little more view right here. And we're going to see whether or not that made the difference. So we'll sync that, and we'll go back over here to the guide camera. Yeah, it's a little bit better. Still could be a little better. But what we'll do is we'll lock on one of these stars right here and start guiding. Then what we're going to do, let's see if we can see where we are. So there's the Eagle Nebula right there. So let's take a little longer exposure. And then let's get a little closer to it. See, this image that we're seeing right now is 2 by 3 full degrees. So we have a very large image, and this is called vignetting out here. To get rid of that, you do something called flats. But I'm not really worried. I still see the stars out here, and it works just fine for my purposes. But what we're going to do is, now that we're tracking, we're going to go ahead and move this up to about a 90-second exposure. Which is about right there, I think. And we're going to hit live stack. Now, while we've got live stack on here, we're going to go ahead and normalize that. We're going to normalize that. We're going to clear this. And last but not least, let's make sure that this is normalized down here and we're not doing any stretch on it. Yeah, we see we don't want any stretch on that one. So now let's go ahead and wait for the first one to come out. And there we are. Let's go have a quick look. So you see, once again, our light colors are separated on their curves. So we hit this right here, and that brings them all together. And that does what's called white balancing. And then we'll go ahead and bring our stretch in. We want that right at the peak. And again, that one there looks pretty good. So let's get rid of that. Now let's get a little closer here and see what we can see. Anybody know what's here? So this is the Eagle Nebula. Let's bring that down to maybe 66% Hale Sagan. So there's the Eagle Nebula. No, there shouldn't be any. Is there an echo out there? Because I don't have anything. I don't have anything going on that TV. Let's adjust this color just a little bit more because it's a little What do you guys see? What's right in the center of the Eagle Nebula? I'm not going to zoom in any further for right now. Let's see if you guys know what's there. It's one of my favorite targets, by the way. Those are the pillars of creation, absolutely. And if you want to see what I'm talking about, the famous Hubble image. See the pillars of creation right here? Let's bring it up to about 150. And there they are. They're the three pillars of creation. You see the one in the back. I'm thinking we might be able to do a little better focus on this. What do you guys think? Let's go ahead and put this on pause for just a second. Turn that camera off. Let's go back on over here. Turn the camera on here. Let's do a quick autofocus. This will just take a moment. So we'll see what we have. Yes, the pillars of creation are a real thing, and you can actually see them from your backyard. It's in the Eagle Nebula, which is 6,500 light years away, roughly, just from memory. But we're going to go ahead and see what the pillars of creation look like. Let's get a nice focus on it first, though. How many folks we have out here now? Oh, 15? We can do better than that. While we're focusing, take a moment and share this around a little bit. Tell your buddies that we're here. And we'll get some nice pictures of the pillars of creation. You know, like I said, a lot of people on YouTube image the moon, and that's fine. These are deep sky images with a much higher quality camera and telescope, and some really good software to do this. You know, I'm going to do this live stream for a couple of hours, and then I'm going to actually do a little bit of science. I'm going to test out to see what level of, what magnitude of asteroids I can spot. Simply because I want to see whether or not the color camera will actually cut it for science. That's the reason that I have the monochrome camera as well, is that it's got, for lack of a better term, it's got a much finer grain. And it really picks stuff up down to magnitude 20, which is pretty amazing, because theoretically I can get down to 20.5. You rarely get to the theoretical maximum, but I have pushed north of 20. So I've gotten pretty doggone close. So you see what it's doing is it's coming down to the focus point, which will be the lowest point on that curve, and then it'll push through the focus point and start going up again on the other side. And it comes up with this parabolic curve, and it uses that to calculate the ideal focus. So for some reason this is reading around an HFR of 2. It's actually an HFR of around 1.3. I don't know why it's reading high tonight. It might be ambient light. It could be the fact that there are objects, a nebula in the image. But this telescope is actually hitting a half-lux radius, which is a measure of focus of about 1.4 or 1.3, which is excellent. Well, thank you very much, Ann. Yeah, you got to hit the button there, folks. I like doing these, but I really appreciate it when people stop by and show a little love to the channel. Hit me some likes. Give me a few new subscribers. Maybe even a member or two or some Patreons. Everything that I have in the observatory was donated by the viewers. And as a result of that, I've got some pretty good equipment out there. And like I said, I do actual science with this. Yep, this is the view from my telescope. So now we're all focused. So let's go ahead and turn this camera off. Boink. Let's turn it back on sharp cap and maybe image that Eagle Nebula for a little longer. See what it looks like. So this is a ZWO 6200 MC, which is the one-shot color version. And this is a top-of-the-line astronomy camera. Absolute top of the line. This is kind of the standard asteroid hunting configuration, a RASA 11 and a 6200. So let's go see what we have here. Let's bring this on up. Let's do 60-second exposures. And we're going to go ahead and hit live stack once again. We're going to make sure that that is unstretched. We're going to unstretch this one. And we'll wait for that first image to come through. Yeah, these are all live images. Yeah, I do the same thing. What is it? Dylan O'Donnell at Byron Bay is one of the guys I watch down there, and of course, Wolfie 6020 does a lot of telescope work. And I've got to admit, I cheat. I have an account at iTelescope, which means that I have access to the telescopes at Sliding Spring Observatory. And those are pretty cool. I mean, I can get up to 61 centimeter telescopes. I have access to them in Australia and in Chile. Ah! Damn, that looks good. I love this stuff. This stuff is way too cool. I can't believe NASA lets me get these images. And I didn't even have to get a subscription service to them or anything. I think that special chip that Wolfie told me to install in the telescope, but wouldn't tell me what it was for, I suspect was a beta NASA chip. It comes preloaded with all this really cool stuff. Yeah, I'm in school right now, and the problem that you run into is I've got really good equipment, but I have really crappy weather. I live in the Great Lakes in the U.S. state of Michigan, and we get a lot of cloud cover and a lot of poor seeing conditions. Now, I am a little bit north of the bad light pollution, but I still have some light pollution here. And, like I said, with the dredging of the lake, it gets even worse. But you see, even just a little tweak in the focus makes a little bit of a difference. So you see how much clearer the pillars are right now? Now, as it comes through in stacks, you're going to see a lot better detail. But I'm in school right now. And my major is astrophysics and astronomy. So part of that is observational astronomy. And I have to actually do a thesis and stuff for my degree. So one of the things that I'm going to be working on is amateur outreach and visual astronomy. And as a result of that, I am going to access some of the telescopes out in Utah and in Chile and in Australia, and maybe even in Spain, depending on what telescope I want to use. And I should be able to get some pretty decent images even if I'm clouded over here. Generally, one of those sites is clear. Yeah, you got a nice Bortle too. Yeah, just to let you know, I'm not in the observatory right now. I'm in the house. This is Michigan. It's damn cold here in the winter. And one of the things that I set this telescope up to do, it's in a 2.2 meter Nexdome. Yeah, I used to work up in the UP, Cheyenne. But one of the things I decided I didn't want to do was be tramping out in the snow in the winter every time I needed to do a tweak on the telescope or move it around or anything. So my entire operation is electronic assisted astronomy, which means that I run it all from inside the house. And the software that I use for that, you've already seen SharpCap. You may have recognized Nina and PhD2 guiding. And the Nexdome Observatory has a remote control shutter and a rotator. So I can rotate it manually, and then once I get it where I want it to be, it'll actually track the telescope. And of course the mount can be controlled remotely. So I don't have to go outside except to close down the observatory at night. I have to go in and power it up. And then I have to go out and make sure that the dome's already closed by the time I get out there. I just need to be able to rotate the dome an inch or so one way or the other to make sure the contacts for the battery charger for the shutter motor are connected. And that's really all I need to do. So where's your friend up in the UP? Do you know? I used to work in Marquette and Iron Mountain and Ironwood and Houghton Hancock. Even did a little time in Sault Ste. Marie. But these are the pillars of creation with 60-second images and nice round stars. Focus is pretty decent. Could always be a little better. I'm wondering if there might be a little haze up there or a little smoke from Canada. I hear they've got some more fires. We had a bad problem with the smoke last year. I mean, well, they had a much worse problem, of course, in Canada because half their damn country was on fire. But, I mean, it was so bad down here. I got up one morning, my entire lake was covered in smoke, and I thought that there was a house fire. I actually called the fire department saying, look, there's smoke everywhere here. And they said, that's from Canada. I'd never seen it do that. You know, I thought one of my neighbor's houses was on fire. I couldn't see a source, but yeah, I always enjoyed the UP. You got nice Bortle 2 skies up there, but the problem that you run into, there's a place in northern lower Michigan, right up by the tip of the mitt, we call it, called Canada Creek. And it's out near Alpena. And it's a Bortle 2 area, and it's really nice. The problem you run into with it is that there's not a lot of internet access up there. And you have the weather at the Straits is horrible. So, I don't know, one of these days I'm going to retire and go out to New Mexico or Arizona or something or other, A, where it's relatively warm, and B, where the skies are a little clearer. Oh, we'll see. Thought about going down to Texas, and then I said, no, not Texas. The Astronomical Society of Victoria. That's got to be cool down there. You've got some beautiful skies in Australia. We don't have anything like that here. But in any event, those are the pillars of creation. So let's go see what other targets we can find tonight. So we'll go ahead and turn off live. And we're going to drop this down to about 4 seconds. we're going to turn off our tracking, or guiding, and let's go find some other targets. This one's going to be tough. This is the Dumbbell Nebula. It's up 52 degrees above the horizon, which means that I'm very near the top of my shutter. You know, the aperture of the dome, the opening, which means that part of the telescope may be blocked. This is the one disadvantage of a dome. So even though my dome kind of opens a little bit further than the zenith, because of the size of the telescope, you know, you have a lot of trouble getting all the way up to the zenith. It's just a very difficult place for me to hit. If you want, you know, if a lot of your targets are up by the zenith, if you're down, you know, a little bit more towards the equator, for example, a roll-off observatory is a much better option for you. You know, a roll-off observatory kind of looks like a shed with a roof that actually laterally displaces. You know, kind of like opening up a garage door. You get them by hand as well. But with those, you have a lot fewer restrictions. So you see, I may have a little trouble right here getting that guide scope to get an image. Let's go see what the guide scope looks like. I'll be damned, that works. I'm going to take that. So let's go on over here. Let's take a nice image. We'll stretch that out so we can see. Let's make it a little bit smaller, you know, kind of look at the whole thing. I don't see the Dumbbell Nebula right off the top of, you know, right off the initial view. But let's go ahead. Let's plate solve and resync and see whether or not maybe we can zoom in on the Dumbbell Nebula. Okay, so we do have a solution. And what will happen now is the telescope will shift slightly to actually zero in on the target that I told it to look at. And there it is, right there, right in the center. You see that? Now, let's go ahead. Looks like we still have a decent guide scope. You know, it's not blocked. So let's go on over here. We'll call this the Flat Earth Nebula. And let's go ahead and take some images here. 60 seconds probably, that's looking pretty good. See, with a RASA, it's got an f2.2, which means that your images, it's a very fast telescope is what we call that. So you don't have to have that long of an exposure. So a 1 minute exposure on a RASA is equivalent to an 8 to 10 minute exposure on a Schmidt-Cassegrain. So let's clear this. And we'll await that first image with bated breath. The Magellanic Clouds. The Carina. You ever see the Finger of Defiance in the Carina? That's always a fun one. Looks like the Almighty's flipping you the bird. Now right down here in the corner is the shot timer, so to say. So when that orange bar goes away, it means that the image is done taking. So we should have the first image here. Okay, good. Now, once again, you see how our light curves are not lined up. So we come over here to the lightning bolt, and that'll line it up and white balance everything. And then what we'll do here, we want the dark edge to be right there at the peak. And we want the light edge to be about where that changes. So You see the size of the dumbbell nebula compared to the rest of the field. Now, with my Ritchie Crayon, the 8-inch Ritchie Crayon, I zoom in more on this area right here. But it's 1,620 millimeters focal length versus 620. So what we'll do is we'll come on up here to about 1,000. Oh man, look at that. These are red stars, not hot pixels, but you can actually, even with one image, you can see the X in the dumbbell nebula. Oh, this is going to look nice. This is what's called a planetary nebula. Yeah, look in the Carina. Look in the Carina for the finger of defiance. Look it up first and then you'll see it in there. It's in the heart of the... But that is an amazing image. I mean, that's a Wikipedia image there. Yeah, I was looking at Andromeda a little while last night. We'll have a look at Andromeda here in a few minutes. I wanted to let it rise up a little bit, get a little higher up in the sky. The reason I switched over to the color cameras, we're kind of pointing roughly towards the Milky Way right now. We're looking at the arm of the Milky Way, and that's where all the interesting nebula are. More during the spring and late winter, we're actually pointing away from the Milky Way, and that's you know what we call galaxy season up here. So we look at galaxies. Oh, you want me to explain what a nebula is to a hillbilly? All right. Well, nebula are collections of gas and star-forming regions. Sometimes they're the result of a supernova or something exploding. And, you know, but basically these are big, areas of gas without a container out in space. And generally they expand, like for example, the Crab Nebula is the result of a supernova that occurred, when did it occur? About 900 years ago. It was observed by Chinese and some European astronomers and some Islamic astronomers and Indian astronomers. So we know more or less when it occurred because it was witnessed. And as a result of that, we could see it, and it's still expanding. And if you look at images of the Crab Nebula over the last century or so that we've been taking photographs of it, you will see that it is continuing to morph and expand. Obviously it's not something you notice in 20 years, but it is something you notice in 80. Yeah, isn't that a beautiful shot? The thing that I really like about it is you see the X? You don't always see that. And it's really coming up nicely. This camera is really good. You get a better view of the dumbbell because, look at the size. So you see the size of the plate and the size of the dumbbell nebula. You want something that's got a lot more focal length, so you're kind of zeroing in on this area right here. My hope one of these days is to get about a 14-inch Ritchie Crayon with a focal length of about 3,500 millimeters, and I'll be able to actually reach out and touch that thing. Now, the other way that you can get away with doing this, but it kind of defeats the entire purpose of having a RASA, is you put a smaller frame camera on there, like a ZWO 5300 or 5330 or 533. 533. There we go. Get it out, Bob. Broca's aphasia strikes again. But that'll have a sensor, a little square sensor that'll only cover this area here. It's about 1/6 the size of this frame. But because this is such a large frame camera, I actually have to use a lot of magnification on it. But I can get a lot more. The problem that you run into is, you start getting blurry. So, that's the problem. Magnification is not your friend. What it does is it just makes blurry things bigger. So that's a nice frame right there. Uh-oh, something happened to Sharp Cap. It failed. Let's restart it. So like I said, the camera we're using tonight is a ZWO 6200 color camera. It's a one-shot color. And it's a nice astrophotography camera. I will test it out later on this evening to see how it does with science, looking at asteroids. Studying asteroids is kind of like watching paint dry. You just take, you take 42-minute images, then you run it through a computer. Let's see, 102 gain, 1-minute image. Let's get back up here. We'll get the dumbbell here. Let's go ahead and hit stack. 0, 0, 0. Now we let that first image come through. Crab Nebula. If I have a 14-inch RC, will I need a new dome? No. That's why I'm not getting a 16-inch RC. 14-inch RC will fit on my mount in my dome, and it will work with the dome. It's the largest telescope that the dome can handle, but it will handle it. And it is below the weight limit of my mount. So my mount is rated for 75 pounds. And the 14-inch RC is so Sharp Cap didn't want to work there. Let's try it one more time. I might have to restart the computer real quick, but I can do that remotely. I'm running the stream on one computer in the house, but the computer out in the dome is separate. I've got a Alienware gaming computer out there that runs the dome and everything. But in any event, let's go ahead. Is this at 4 seconds? Yep, that's a 4-second shot. But in any event, that was the Dumbbell Nebula. Let's come down here and see if we've got anything else. Do we have the Crab Nebula up? There's the Cocoon Nebula. My apologies. My eyes aren't the best. But I don't think I see the Crab Nebula out here. Now the Cocoon Nebula, that's to the northwest at 35 degrees. That's right at the top of the trees. Let's have a look at M15 just to see. We started off with Carolyn's Rose tonight, which was an open cluster. Let's see a globular cluster for comparison. Yeah, focus is key always. Let me just finish maneuvering this scope. That may actually work. It didn't. You know what may happen? That's what's happening right there. I didn't turn the guiding off, so it was jiggling. Let's try it one more time. There we go. See, that's solved. It's very, very sensitive. See, if I was smart, I'd be overlooking at the TV because I can see that a little bit better. Okay, so there's the cluster right there in the center. Okay, so let's go ahead. What did I say this one was? M15? Yeah. So let's go ahead and hit M15 here. And let's clear that. Let's come up here to a 60-second exposure. Come on. There's a 60-second exposure. Let's go ahead and hit live stream. Clear this. Normalize that. Normalize that. Let's go see what we see here. So you see how small the cluster is. Now you can actually see this one with binoculars. You know, if you've got a decent set of binoculars, you can get one that's there's a model called Hunell, which is Zhenell, I believe, and I have they're 100 millimeter binoculars, and they're 25 power, and they're crew serve. They're huge, but they come with a stand, you know, like a tripod. And you can actually see a lot of, you can see all the C's on the moon, for example. You can see stellar clusters. There's a lot of stuff that you can see with those. So, you know, I used to say the first telescope you should get is a pair of binoculars. I wonder if there's an issue with the... let me double check and make sure that my disk isn't full. Yeah, shoot, something's locked up here. Yeah, I may just have to go ahead and I may have to reboot that computer out there. So you see, I'm getting all sorts of error messages. So I'm thinking what I may do is I may end the live stream, and then I may come back, you know, I'll reboot the computer and everything, and then what I may do is I may come back and start streaming a little bit more here, in half an hour or so. and we'll kind of pick up where we left off. And I'll take that opportunity to go ahead and bump up the resolution if I can. We'll see how that works out. All right. So why don't I do that? Why don't I come back in about half an hour? Yeah, Crab Nebula is red below the green list, and that means that it's not available right now. So in any event, we'll go ahead and take a little break for about half an hour, just kind of do a little equipment maintenance real quick, and then I'll be back and we'll do this again, okay? Thank you all very much for stopping by. Make sure you follow my channel. And hit that subscribe button if you want to become members or make donations via Patreon. There's a link for that there. And all those donations actually go into equipment for the channel. I don't take any income from it. I just put it right back into the channel to get better content. So